So the argument is the innermost part of a function. Innermost part. So most of the time when we do U-substitution, we're going to learn about U-substitution in a little bit, but most of the time is where we start with U-substitution is what's called the argument of a function. It's the innermost part. The innermost part is usually where we start, right? If you're doing an equation, right? If you're doing one of these guys, something you guys have done probably a long time ago. Like if I give you a problem like this, right? If I give you a problem like this, where would you start? Mm-hmm. Yeah, the parentheses, right? That's the innermost part. That's where you would start, right? You guys did this probably in 8th grade, 7th grade. Order of operations. It's called order of operations, right? That's what we're looking for with these guys. So sometimes they're lucky enough to give them parentheses. That's usually where you start. Like first one, parentheses, right? P, right? That's the argument. Okay? Sometimes they don't. Like the second one. Well, where's the innermost part? There are no parentheses, so we got to skip parentheses. So what's the next one that we look for after parentheses? Exponents. E, exponents, right? Well, this one doesn't have parentheses, but it does have exponents. So that's the argument. That's where we would start, right? We would do the power first. The third one's kind of tricky because it's got parentheses. But where would we start?
Go on a limb here and say root x plus 10x.
Well, so one has parentheses and one doesn't. But this is what's called a grouping symbol, right? This guy right here is what's called a grouping symbol. That's all parentheses are. Parentheses are just grouping symbols, right? So technically they're both inside of grouping symbols, right? Some teachers taught PEMDAS. What's the other one? Some of you guys learn GEMS, right? Some of you guys learn GEMS. I teach GEMS when I used to teach 7th and 8th grade. I taught GEMS because GEMS was a better way of describing it. GEMS is, oops, for those of you that don't know, GEMS is, G is grouping symbols, E is exponents, M is multiplication / division, and S is subtraction / addition. So it's kind of like PEMDAS, but a lot of teachers use that because grouping symbols is a better way of describing it than just parentheses. And a lot of teachers don't like, me included, PEMDAS because PEMDAS makes it seem that division is not as important as multiplication. And addition is more important than subtraction. That's not the case. They're both equally important. So this D should be over here and this A should be here, right? So that, going back to that, that's why I don't say parentheses. Grouping symbols. So we have two grouping symbols. The first one doesn't have a power. The second one does have a power to the 1/2. That's why that one is our argument. That one is our argument. Okay? And then the last one, it's got parentheses. This is our argument. Okay? So U-substitution is a way of integrating, which is a way of finding area under the curve, right? We have different ways of doing it. You guys did it on the quiz, right? Actually drawing it, finding area under the curve, using properties, using trapezoid or rectangular approximation methods. And the last one was antiderivative, okay? Well, U-substitution is using antiderivatives. So we're going to be using a lot of antiderivatives today. That's the one we're going to use most of the time throughout the year. Okay? So what is U-substitution? So when we're finding derivatives, we have the chain rule, right? We had the chain rule. We had all these types of rules for the, let's see if I have still have it up here. We had all these types of rules, right? Lots of rules. The main one we used was chain rule and power rule. Well, for antiderivatives, we only have one rule so far. Power rule, right? Add 1, divide by the new function, or by the new power. So to make up for all those other rules, we have U-substitution. So U-substitution is kind of the chain rule for antiderivatives, okay? So integration has a similar method called U-substitution, U-sub. We use U-sub anytime we cannot integrate only using the power rule. Anytime we can't just use the power rule, we use U-substitution. Okay, so it's got 8 steps. It's not very hard if you follow each of those 8 steps, okay? So the first one is to investigate to see if the power rule by itself will work. We can use the power rule, like on your quiz, use it, okay? Power rule is the easiest one to use. Use it. If you can't use it by itself, then you have to use U-substitution. If not, we need to find the argument, the inside of the function. That function is going to be called U. Okay? Find the derivative of that. Okay? Then we're going to solve that equation, du equation, and then substitute. So that's when we substitute. That's where the substitute comes in. And then we move any multiplied constants to the front. And then we integrate. So when I say integrate, I mean antiderivative. Find the antiderivative. Okay, when I say integrate, that means find antiderivative. Don't forget the plus c. Move everything back in the way it started. You're done. Okay, so the first example number 2, I want you to circle the argument. And then we're going to actually use U-substitution. So circle the argument for A, B, and C, number 2. Just like we just did earlier. Okay, so hopefully you circled those ones there. Okay? Okay. So first one we're going to do is we're going to actually do U-substitution for this guy. Now, could I use the power rule for this guy? Could I just use the power rule for this guy? Is this a question I could have given you on the quiz yesterday and you could have done it? Yes, it is, right? It is. It's to the third power, right? The argument is to the third power. The argument is right here. Right? That's to the third power. You could have multiplied it out and then distributed the 2x and find the antiderivative. You could have done that. It would have taken you a little bit of time, right? But you could have done that. Well, I'm going to show you how to use U-substitution for this guy. Okay. So the first step is, if you can use power rule, use power rule. We just talked about that. Second step, find the argument. Let that be U. Done. So what I'm going to do over here is I'm going to say U equals the argument, x squared minus 1. Okay? That's the first step of U-substitution. The next step, find du by taking the derivative of u. Okay? So du equals the derivative of u. Well, what would the derivative of u be? 2x, yeah. But don't forget about the dx. The dx always goes, because you're finding with respect to x, right? So the dx goes there. Because we're not living in the x world anymore. We're living in the u world. So that's why I need the dx. Okay? Next step. Solve your du equation for dx. Okay? So the du equation, I got to solve for dx. So how am I going to get dx by itself? Divide by 2x, yeah. Divide by 2x. So instead of dividing, I'm just going to put 1 over 2x. Okay. That's my next step. Done. That was number 4. Number 5. Now I'm going to substitute in u and du to the original equation. Okay, so I'm going to rewrite the original. But I'm not going to use x's. I'm only going to use u's and du's. This is where the substituting comes in. So anywhere I see an x squared minus 1, I'm going to put a u. Okay. Right. 2x, I just have to put 2x. dx, what is dx equal to? So that's what I'm going to put. Instead of dx, I'm going to put 1 over 2x dx. What happens to the x's and the 2's? They cancel out, right? They make a 1. They make a 1. Oops, that's not a d. It shouldn't be a dx. It should be a du. Okay. So now what I'm left with is the integral or antiderivative of u to the third power du. Okay. Once I substitute, it says move any multiplied constants. I don't have any multiplied constants anymore. No more multiplied constants. At this step, you should have no more x's or y's or a's or b's. The only thing you should see is a u and a du, u's and du's. Okay? All the x's should cancel out like they did right here. They should all cancel out like they did right there. Okay? If they don't, you did something wrong. Next step, number 7, integrate. Find the antiderivative. Now for this guy right here, can I use the power rule for this guy? Yeah, right? Add 1 power, divide by the new power. Add 1 to the power, divide by the new power. Plus c, right? Just like you guys did on your quiz. Very, 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 very last step, move everything back in. So what was u equal to? So I'm going to put that back in. And you are done. Okay? There's a lot of parts to it, but the parts kind of flow together. Okay? So that is the antiderivative of x squared minus 1 to the third times 2x. Okay? That's the antiderivative without using the power rule, by using U-Substitution. Okay? All right, let's go for the next one. Well, this is letter B. You guys already letter B, you guys already circled. You guys already know what the argument is, right? This one, there is no possible way that I can find the antiderivative just by using the power rule, because it's got a root, right? I can't use just the power rule. Okay? So what I can do is rewrite it though. Just like with derivatives, I don't like roots, I like powers. So I can't use the power rule. So my only option here is to use U-substitution. Well, I've highlighted the argument. That's your first step. If you don't know where to start with your argument, because more than likely that's where you're going to start. Okay? Next thing is find U. That's your U. X to the third plus 2. If that's your U, what is du going to be? 3x squared dx. Next step, solve for dx. Divide both sides. One over 3x squared du equals dx. Okay. Substitution time. Substitution time. So I'm going to move in. Anywhere I see an x to the third plus 2, I'm going to put a u. And everywhere I see a dx, I'm going to put 1 over 3x squared. Okay. So 3x squared times u to the 1/2 power times, instead of dx, I'm going to put 1 over 3x squared du. Okay. Simplify. Well, I got a x squared there and an x squared there. That should always happen. Now, will this 3 and this 3 cancel out evenly? Not always. Then I can have numbers, constants. I can't mix x's with u's. So if you have any x's left, you did something wrong somewhere. So I have left u to the 1/2 power du. Find the antiderivative. Add 1 power, divide by the new power. When you divide by something, you're just multiplying by the reciprocal. So instead of dividing by 3 over 2, you can just multiply by 2 over 3 plus c. Last step, move everything back in. Done. Okay. Let's see. Try number 4. Try number 4 on your own. Use the steps to do number 4. Again, number 4, you could use the power rule, but it would take you a long time because you got to multiply some 3x minus 2 4 times. And that would get very long. Okay. So your u is 3x minus 2. So your du would just be 3. Solve for dx. Plug it back in. So everywhere you see a 3x minus 2, I plugged in a u. And then everywhere I saw a dx, I had to plug in this guy there. Well, 1/3 is a constant. It's okay. Doesn't have an x, so it's okay. You just move it to the front. So you're left with u to the 4th du. Add 1 to the power, divide by the new power. 3 times 5 makes 15, 1 over 15, u to the 5th plus c. Put in back everything where it came from, and you're done. Okay. All right. All right, try letter B now. Try letter B on the next page. Try letter B on your own. Give you some time. This is all about practicing. U-substitution is not complicated, but it does take practice. Okay? So the first thing you always do, just like when we did derivatives, anytime you see a root, change the root. First thing you should do is change the root to a power. In calculus, when you're finding a derivative, when you're finding an antiderivative, roots don't really help us. Powers help us because we have power rules and chain rules and U-substitution. So change it first. Okay? That'll be your u. Find the derivative of u. So u is 5x plus 4. Du would just be 5 dx. Solve for dx. Plug everything back in. 1/5 is the constant. 1/5 is just 1/5. It's not 1/5 x, or it doesn't have any x's. X's are all gone. So you move the 1/5 to the front. And then I have u to the 1/2. So I find the antiderivative of that. Add 1 power. Divide by 3 over 2. Well, dividing by 3 over 2 is the same thing as multiplying by 2/3. So 2 times 1 is 2. 3 times 5 is 15. Move everything back in. You are done. Okay? All right, let's try letter C. Okay, letter C. We'll do this one together. This is a trig, right? Trig. So now we're going to move in some trig stuff. Okay? Now, it's sine. What is it sine of? Sine of what? 3x. So sometimes they won't put parentheses, but I will. I always put parentheses. That's why I always put parentheses. Whether I'm teaching Math 2 or I'm teaching calculus, I always put parentheses around whatever. Sine of what? Cosine of what? Tangent of what? Because I know it's important to know, especially for us, because we're finding antiderivative. So sometimes they won't do that. You need to do that. Okay? Because then it tells us where to start. That's the argument. All right? So u is going to be 3x. That means du is 3 dx. Divide by 3. 1/3 du equals dx. Okay. Now it's time to move everything in. So everywhere I see a 3x, I'm going to put a u. And everywhere I see a dx, I'm going to put a 1/3 du. Okay. No more x's. There's no more x's in there. It's just u's, which is what we want. I have a constant here. I'm going to throw that out in the front. So it's 1/3 antiderivative sine of u du. So what's the antiderivative of sine? Negative cosine, good. So it's 1/3 times negative cosine of u plus c. You can move the negative to the front. Negative 1/3 cosine. U is 3x, so I'm going to put back the 3x and put the c. And you are done. Okay, so it's the same way. We use it the exact same way we've used, or similar to what we used to do with derivatives. Not the exact, but similar. Here's my question. If I can remember my question. What was my question? Man, I forgot already. If it comes back to me, I'll go. Oh, that's what I know. Go to the very front. Go to the very, very front of your notes. It says U-Substitution, right? At the top. With what? Indefinite integrals. I know what an integral is. I know what U-Substitution is now. What does indefinite mean?
There are no bounds within the integrals.
Yeah, there's no numbers, right? On your test, on your quiz, you get a bunch of these, right? -1 to 7, right? Almost all of them, almost all of the integrals had something like that. 1, 2, 3, and 4 did. 5 is the only one that didn't, right? That's what we're doing today. We'll come back to those. We're going to do those probably next week. But anytime there's no bounds is when it's indefinite. And with indefinite comes a plus c at the end, okay? When there are bounds, you don't need a plus c because it's definite. When it's indefinite, that's when you got to put that extra constant out there, okay? All right, so let's go to the next problem, which is letter D on this page here. Okay, so this one's a little tricky, but once you kind of get it, it's easy. But the hard part is getting it. What is the argument going to be? I'm glad you guys are thinking. Most class just says x. It's just going to be x, right? Because isn't it natural log of x, right? Most classes say that. It's actually not, right? It's actually not going to be that. Because if let's say, don't write this down, but if let's say I said, okay, x is it, all right? du is 1 dx, right? And then I divide by 1, so then I get du equals dx. And then I move everything back in. Well, then I still have a division. How do I do that, right? I don't have a quotient rule, right? So I got to figure out a way to figure out a u that will help me, right? So that doesn't work. What will help me is this. I'm going to break this guy apart. We don't have a quotient rule. So I don't like to write things as fractions. When we're doing antiderivatives, we do not have a quotient rule. So I don't like to write things with division. I like to write them separately. So how do I write it separately? I separate them like this. It's really multiplication. One of them just happens to be a fraction. That's why it's a division. Okay, so now I have two guys. Let me highlight them. I got a blue guy, and I got a pink guy. We know x doesn't work, right? We just said x can't be u. One of those guys is going to be u. The other is going to be du. Your question I'm asking you is which one is going to work? Is it going to be the natural log of x, or is it going to be 1 over x? There is a right answer, but don't try to get the right answer the first time. Let's do a little practice. Let's say it's going to be natural log of x. Let's say it's the pink guy. We're going to do a little trial analysis, trial by error, see if it works. So let's say, okay, the pink guy. du. What is du going to be?
1 over
Good, 1 over x. Yep. dx. Is that derivative in the problem?
Yes.
We didn't realize this the first couple times, but you guys have actually seen this before. We just didn't realize it. Let me go back here. When we found a u, was du in the problem for letter B?
Yes.
Right? When we found a u, was du in the problem? Yeah, it's right there. Let's go back to A. When we found a u, was du in the problem? Always look for that. Always look for that relationship, right? It wasn't here, but a number I can deal with, right? Because it just becomes 1/3. But especially if there's something else there, look for that. What du would give me something in there, right? So if I had switched these out, don't write this down, but if I had switched these out, let's say I had put 1 over x here. The derivative of 1 over x is negative 1 over that. Is this guy in there? No. So that's how you know what should be your u and what should be your du. Because we want things to cancel out. We want things to cancel out. So watch. What's my next step? After I find u and du, what's my next step? Find dx. Solve for dx. Divide by 1 over x. Divide by 1 over x. When I divide by 1 over x, what is that really doing?
It's just adding an x.
It's multiplying by x, right? So it'd be x du. Dividing fractions, you're multiplying by the reciprocal of the bottom. Okay, let's put everything back in. Okay. Will the x's cancel out? That's what we want. I don't want to have x's anymore. I just want to have u's. So I just get u du. Had I chosen 1 over x as my u and then put it back, it wouldn't have canceled out. The x's would not have canceled out. That's how you know I did something wrong. If after you do substitution, you should not have u's and x's mixed up. You should just have u's. Okay? If that's the case, if you get here and you still have x's in there, I would say you picked the wrong u. You picked the wrong u. Go pick another u. Okay? That's how to kind of check as you go before you start going. Okay? All right, last thing. Antiderivative, u to the second power divided by 2 plus c. Move your u back in. You were done. Okay? That's really what U-substitution is. U-substitution is the same thing over and over and over again, but there are different functions. You have polynomials. You have trig. You have natural logs. You have regular logs. You have exponentials. You have all these different types of functions. So what we're going to be doing is just doing practice. Practice, 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 giving you different looks to see. And I'm telling you right now, if you pick the right u, your job's easy. Your job's easy because you do the same thing over again. But this is the mistake I see the most, not picking the right u. If you start off on the wrong foot, it'll just snowball. And eventually you'll get here and you're like, what? My x's aren't canceling out. Go back to your u, pick a different u. Okay. All right. So we will continue tomorrow.